All right, so today we're going to be doing sum of two integers. This is a Leetcode medium problem, and let me just tell you straight off, this is a binary problem. Now, binary problems are stupid, you feel me? They just test if you know some trivia about binary, nothing to do with any other problem except, I don't know, being an IQ test, but I'm gonna show you how to do this one just so you know, because it looks like Amazon, Adobe, and Facebook all ask how you might do this problem. So first things first, how do we do addition normally, right? Let me just give a little example here. 999 plus 9999. And you can tell that this example is set up so that you have a lot of carries, right? Because if we add here, it's 18, 10 plus 9, what's that? 19. This is 10, but what's that? 10, 19, and yeah, you have this being the answer, right? So obviously that's how you do regular addition, but that's not what the problem is testing us on. It's testing us on how we do binary addition. So let's walk through that a little bit, and honestly it's not much different. You don't need to watch a video to figure out how to do binary addition if you can already do decimal addition, or I guess base 10 addition, right? Binary is just base 2, so it is a little trippy, but keep that in mind. So let's go ahead and do a similar example. We're going to do 1111 plus 1111, and remember this isn't binary, so what is this actually for saying base 10? Well, this is, let me use a different color here. This is 1, this is 2, this is 4, and this is 8. So what we're really doing is 1 plus 2 plus 4 plus 8. What is that? 15. And then plus 15. That's what we're really doing here. So we need to make sure our answer is correct. But so how do we add this? Well, 1 plus 1. Well, this is going to be 2, right? But 2 is going to be 1, 0 in binary, right? So we need to carry it over. So we just have the 0 at the end, similar to as if we had like 9 plus 1, right? This would be 0 at the end, and then the 1 would carry over. So let's go ahead and do that. So we're going to make this 1, 0, and then 1, 0 plus 1. What is that? That is 1. And then now we have a carry again. So this is going to be 1, 0. And then what is the carry here? Well, it's 1. And then now this is going to be 1, 0. So the carry will go down here. But first we're going to write this 1 here. And then the carry, you can see it got shifted to the left. And that's 1. Okay, so let's go ahead and see if we are correct. So remember, this is 1, this is 2, this is, this is 2, 4, 8, and we even have 16 here. So 2 plus 4, that's 6, 14 plus 16, what is that? That is 30. So we got the right answer because these two, sorry, I keep fat fingering, these two are the same. So we are good here. We know how to do binary addition. Now, what is this problem asking us for? Well, it's asking us to code up binary addition. The easier way to make a computer do binary addition is a little bit different from our human thinking process. Instead of trying to code exactly this process up, where we have to go digit by digit and remember the carry, I mean, it's pretty easy for us humans to do, but to code it up is a little bit more complicated. So there's actually a little bit more of an ingenious way of doing addition, and I believe it'll make sense once you understand the binary operations we're working with. So I'm going to introduce two concepts here, right? When we have our problem, we need to figure out what the digit will be at a certain point. And what do I mean by that? Well, what will the result be, for example, if you add 1 and 0? Obviously, it will be 1. What about 0 and 1? We're doing very basic binary additions. It's going to be 1. What about 1 and 1? It's going to be 0. And for 0 and 0, we know it's going to be 0. And will this 1 and 1 be just 0? No, there's going to be a 1 carried over, but let's not worry about that yet. We just know that at that digit, right? Like if we're just thinking about a single digit that goes under this column, it's going to be 0, 1, 1, and 0. Now, what operation kind of gets our result the way that we want it to be? Well, it would be an operation that results in 1 for, let me change this, 1 for these and 0 for these, right? And there is an operation that does exactly that. It's called XOR, okay? XOR. So XOR is the operation we want to use to figure out what digit it would actually be. Now, how do you figure out the carries in addition? Because remember, in this case, right, the answer here is actually 1, 0. There's a 1 being carried over. It's being shifted to the left. Well, what corresponds to this special case? And let me use a different color so it makes a little bit more sense. What corresponds to this special case? I'm going to use green. This is a bit of a special case for the carry. We only carry when there's a 1 and a 1. Now, that special case is called AND, right? So AND. Let me be consistent here. So we have XOR. So we have XOR for these, and then AND for this. Because think about it. 1 and 1 is equal to 1, right? This is the result of AND. And for XOR, we have 1 and 0, or 0 and 1 being equal to 1, respectively, right? So if we're able to keep this in mind, we're able to get everything you need for addition. And the AND case will take care of the carries, right? If we also do one other thing, which is shift it to the left 1 bit, right? And then the XOR case will take care of the actual result that you'll see before the carries are taken into account. So if you can think of addition as to split into two parts, we have the column as well as the carries. We can just combine those two parts until we have successfully finished the addition. Let me walk through an example which I feel like will illustrate this the best. Let's work through a simple example, which is 101 plus 110. So the first step we need to do is XOR, and then we can do AND. And then remember, since AND is a carry, we're going to shift it to the left 1 bit. In XOR, it's fairly simple. We're just going to start with 1 and 0. They're different. 0 and 1, they're different. So XOR is 1, right? But 1 and 1 are the same, so it's 0 here. What about AND? Well, first of all, AND needs to be shifted to the left 1. So when we look at 1 and 0, we're going to put this digit here. And 1 and 0 is 0 because 1 and 0 is not the same. Same thing with 0 and 1. They're not the same, but 1 and 1 are the same. So it's going to be 1. And remember, everything should be aligned here. Now, let's go ahead and continue. So we have our XOR step and our AND step being shifted to the left 1. And remember, we can just fill in a 0 here because that's how this works, right? The 0. So let's go ahead and do a quick XOR. So XOR is going to be 1. Same thing with this. And XOR is going to be 0 here, and it's going to be 1 here. What about AND? Well, AND is going to be 0 here. It's going to be 0 here as well. It's going to be 0 here as well, and it's going to be 0 here as well. So we've actually finished our problem. Now, how do we know we finished our problem? Well, clearly doing XOR on this is going to get the same result. Let me get rid of this horizontal line. It's a little confusing. So clearly proceeding here would be meaningless. Why is that? Well, let's say we were to continue on. XOR of 1011 with 000 would just be the same thing. So obviously we don't want to continue forever. So this is where we know that our process of adding the two numbers is finished, when this value here is 0, right? That's when we know that we're done. And if you think of these two integers as variables, right, a and b, let's say we're trying to add these numbers a plus b, you know that we are done then when b is equal to 0. So let's just do a sanity check and make sure we've added these numbers correctly. So this number, remember, this is 1, this is 2, and this is 4, right? So this addition is actually doing 5 plus 6. And what is 5 plus 6? Well, 5 plus 6 is equal to 11. And what is this result? This is, remember, 1, 2, 4, 8. So 3 plus 8, that is indeed 11. So if we go ahead and cross-check here, we know that we have figured out the algorithm. Let's go ahead and code this up, and now it should make a lot more sense. So let's go ahead and code this up. I'm going to be using Java. This is another reason why I don't like binary questions or bit operation questions, because there is a technicality with Python where integers are infinite. So essentially it screws with some of these bit operation questions. Don't think about it too hard. You'll be able to understand it in Java too. So first things first, let's recall what our method is. So XOR is for the part without carries, and then and for the part for the carries, right? So how should the structure of our code be? Well, if you remember our example, we were looping through and we were continuing until b is 0. Remember that? So let's go ahead and make a while loop, and while b is not equal to 0, we need to keep working, and we need to keep going through this addition process. Now, how do we do this addition process? Well, remember, we needed to XOR a and b, so we'll store that in a variable called temp. And then we need to carry, right? We need to do the carries, and that's going to be a and b. And not just a and b, we're going to go ahead and shift this to the left, because remember, when we carry things over, they need to be shifted to the left 1 digit. This is the same in base 10 addition, so it's the same in base 2 addition, which is binary. And if we go ahead and do that, we're going to have temp and carry. And now what is temp going to be? Well, temp will be our new a, and carry will be our new b. So that is how we do this. B will eventually be 0, and a will be our answer. So let's go ahead and run it real quick. And I screwed up somewhere. I need to have a bracket there, and you can see it's passing these test cases. Let's go ahead and see if it passes every test case real quick. And you can see that it does. Now, remember, if you just look at this code straight up, it doesn't make any sense what we're doing at all. But once you really understand what XOR is and is doing, you will understand this. This question is essentially just testing you whether you know XOR and you know and maybe you paid attention in class when you were going over bit operations and how early computers worked, but really don't worry about it too much. All right, that's it for this video, and thank you for watching.